So you're looking at two molecules called canflavin A and canflavin B. You're looking at a third molecule called canaprine and a fourth molecule called cannabis stilbene. There's molecule 5 and 6, which I won't get into right now, but those four are your main players. You can't commercially buy these. They're not available. You can't synthesize them classically through like chemical means, as most drugs are made. So the only option is to get them from the plant at this point, which is not really an option because, as Akeem talked about in his presentation, they're present in such low amounts, it would have to grow fields and fields of cannabis to extract them out of the plant, which is a very, very arduous and labor-intensive option. In fact, it's not an option, it's just not feasible. Okay, so that's issue number one. Where we come into play, and this is the question I had, is how can we get at these molecules in an easier way? And so we took a two sort of pronged approach. We took a classical extraction approach that we could talk about in a second, and then we took a more biotechnology approach. The classical extraction approach is more suited for natural products because it's essentially an extract, but it's an enriched extract. And we developed a technology that can specifically target these particular molecules. So in other words, we can go in and we can take fields and fields of cannabis, even waste material from that space, and we can process it and extract specifically these molecules out of it. So that gives us a capture technology where we can now concentrate these molecules so they're no longer so scarce, especially if you're dealing with waste material, for example, which is easy to come by. And that gives us a natural product extract that can be fed into a variety of different markets, which I'm sure Akeem can talk to you about. But essentially it's an ingredient, and it's an ingredient that contains these four molecules that we talked about, and we're able to concentrate them down using a proprietary technology that Akeem and his crew are using currently. The second approach is more biotechnology, and for those of you who are not familiar with that, I know it gets a bad rap, but essentially what it is we're trying to find another way to do what nature does, but in a different and more efficient system. And so while the cannabis plant and hemp plants make these molecules, we thought we could do it better. And we thought we could do it better by doing exactly what I was talking about in the very beginning, about understanding how things are made in parts. And once you understand the parts and you know how to get to them, you can assemble them in clever ways to do things better than nature does. And that's exactly what we've done. So we figured out essentially what the genes are in the cannabis plant that are responsible for making all four of these molecules. And once you have access to those genes, you can put them together in different systems. I won't get into the details, but you can put them together in different systems to sort of mass produce single molecules. So now you're going from a natural product extract to a single molecule, more pharma-driven type of approach, if that makes sense. And those are the two pots that are boiling right now, so to speak. Does that make sense to everybody?
I think that. Oh, do we have a question? Oh, is it someone? Oh no. I was gonna say, Tariq, I think that makes sense, and I think it's really, really powerful what you're talking about, and the hidden benefit there. If you could just expound on a little bit, is you can't know what to extract, or if you don't know what you're looking for. So can you just talk about that benefit that we have again with the being able to produce these pure molecules and being able to use them for standards? Sure.
So like Akeem said, the only way that you can measure anything is if you have some baseline to compare it to, right? And so anyone who's looking into a cannabis plant, if they're doing QA or QC testing or a hemp plant, they don't have the availability of the canflavins or the canaprine or the cannabis stilbenes because they're not commercially available. And getting to them from the plant is not child's play. That's something that is very, very difficult to do. So there's really no source of these molecules, but we have them and we have a library of them. So, and the other thing that we can do is we can make them. And so that affords us the opportunity to look for them in a variety of materials, to quantify them, and then ultimately to mass produce them, right? And so that's the advantage of being able to understand how these molecules are made, and then being able to make them in the approaches that we use.